This is Enrique Herrera, your professor, and right now I wanted to address the concept of random variables. The reason for this, there are some concepts in here that may be confusing for some people, and I wanted to clarify it just so that if anybody is having any issues, they can address them. So let's consider the approximation of having two tosses of a fair coin. Well, this is a random variable. Is a set of values that are obtained through a random process. And that random process is also called the random model. When you do the experiment, or when you obtain the random variable, you go through a series of iterations. You do one experiment, two experiments, etc. And also you have a probability associated with this value of your random variable. So let's take in this example the concept of a fair coin. In this case, the coin is the model, is the random model, and you can have this random model only has two different outcomes: heads or tails. Heads or tails, and they are of equal probability of 1/2. In that case, you get tails or heads, each one with the same probability of 1/2. So let's say now we're gonna consider two tosses. Well, how can that happen? Let's say you could get one heads in the first toss and a heads on the second toss, or you can get heads tails, or you could get tails heads, or you could get tails tails. Well, if you get this outcome, then you get two heads. In this outcome, you will get one head, in here one head, and here 0 heads. If you count, these are on the only possibilities for the two tosses approximation, the two tosses experiment. And what happens is you get 4 possible outcomes. In this case, this happens 1 out of the 4. You get 1 out of the 4 for one tail on the second toss. One tail on the first toss will be 1/4, or two tails, or meaning 0 heads, will be also 1/4. So you get 2 heads with 1/4 of the time, and the probability for that then is 0.25. But you get heads and two different possibilities, then that means you get one head 1/2 of the time, or 0.5, and you get two tails, meaning 0 heads, with 1/4, or 0.25. Well, this is the probability. So you get 2, 1, 0 with probability of 0.25, 0.5, or 0.25. This is the random variable with the values that I can take 0, 1, or 2, and this is the probability associated with it. What happens is, do not confuse the random variable with the possibilities for the model. The possibility, you have 4 possibilities with the model, 1, 2, 3, 4, but this is all the possibilities you have. That's not the random variable. The random variable is the count that you define here, 0, 1, or 2. Another possibility of confusion is that you have one toss in which you can get heads or tails, and another toss in which you also can get heads or tails. And some people might confuse the iteration with the random variable. The random variable is the count. You have the count, and is a probability associated with each one of those. Now you can also then take this and plot the number of heads versus the probability. So if you say this is 0 and this is 0.5, over here is 0.25, then your probability will plot will look something like this. It's just, this is the distribution of the probabilities. Well, the next question is, how can you make this model, the coin, not a random variable? Well, that's only if one of the outcomes influence the model, therefore influences the rest of the possible outcomes. Let's say that I throw this, and now my model says every time I throw it, I actually eliminate the outcome. Let's say now I throw tails and I eliminate tails, and I said now this coin only throws heads. Well, tails has influenced the model, and now tails is no longer possible, and now heads. Notice that I didn't know what one was gonna come out. I just said whatever comes out I eliminate. But because that outcome eliminated the next one, this is not a random model anymore, and therefore not a random variable. I hope that this helps. Let me know if this video was useful, and I will continue posting some videos here and then.